A star is racing through space near the center of the Milky Way, then suddenly bending into a sharp turn. It does not drift away. It does not escape. Again and again, it follows the same extreme path around a location that appears completely dark. That star is called S2. The strange part is not that it moves. Everything in space moves. The strange part is how tightly it curves around a point where nothing visible seems to exist. If there were nothing there, the star should continue on its way. Instead, its motion keeps changing direction, as though something is gripping it from the darkness. The result is difficult to ignore. A hidden object is controlling the orbit. The star behaves as if it is circling something enormous, yet telescopes reveal no bright source, no visible structure, nothing that appears capable of dominating the motion. At first, that might sound like an observation waiting for a better explanation. But the orbit did not go away. And every time it returns to the same dark location, the simplest escape route disappears. Something is there. The star keeps forcing the same conclusion. The question is how anyone can know what it is when there is nothing to see. The easiest explanation still seemed available. Maybe the dark region was not a single object at all. Maybe it was a tightly packed cluster of ordinary stars hidden from view. If enough stars were crowded together, their combined gravity could pull on S2 and force the orbit that was being observed. For a moment, that idea appeared to work. The cluster explanation did not survive because it was convincing. It survived because no observation had killed it yet. Then the measurements kept improving. The orbit of S2 was traced more precisely, and the requirements became harder to satisfy. To produce the motion that was actually being seen, millions of solar masses had to be squeezed into an extraordinarily small region. That changed the picture immediately. The invisible mass could no longer be spread across a large area. It had to fit inside a space so compact that the cluster explanation started losing room to survive. The problem was not finding enough mass. The problem was finding somewhere to put it. Every new calculation pushed the same constraint: more mass, less space. A normal cluster of stars could sound reasonable when viewed from a distance, but as the allowed region kept shrinking, the explanation became increasingly unstable. The stars would need to occupy an impossibly crowded neighborhood while somehow remaining there. The simple answer was not completely gone, but it was no longer standing comfortably. And as that option weakened, the mystery became even harder to explain. It did not disappear under closer inspection. Year after year, astronomers kept watching. The orbit of S2 continued unfolding across the sky, tracing the same path around the same invisible location. Each new measurement added another piece to the record. Each completed section of the orbit provided another test, and the concentrated mass model kept surviving. The star moved. The calculations were updated. And each update created another opportunity for the explanation to fail. It never did. That mattered because the alternative explanation had not completely failed. A remarkably dense concentration of matter still appeared capable of producing the behavior being measured. It was an uncomfortable possibility, but it remained a possibility. As more observations arrived, the hidden mass kept behaving like a single object. Nothing drifted apart. Nothing spread out. The picture refused to break. For the moment, there was no decisive contradiction forcing that explanation to collapse. The dark region remained hidden. The star remained trapped in its extreme path, and the idea of an extraordinarily dense concentration of matter remained standing alongside the observations. That did not prove the explanation was correct, but it meant it could not yet be discarded. If that interpretation was going to survive, future observations would need to keep telling the same story. The turning point did not arrive in a single observation. It arrived because the observations refused to change. S2 completed more of its orbit. The measurements became sharper. The uncertainty shrank. What had once been a rough picture gradually became a detailed one, and the hidden mass remained concentrated in the same tiny region. That created a growing problem for the alternative explanation. The explanation needed room to survive. The measurements kept taking that room away. With every improvement, the hidden mass was forced into an even smaller region, while the evidence for its enormous size kept growing. The two trends moved together. More mass, less space. Again and again. The consequence was visible in the calculations. The dense cluster idea was no longer struggling because it lacked imagination. It was struggling because its predictions were becoming harder to reconcile with what was actually being observed. The orbit never changed. The explanation kept changing instead. What once looked reasonable now survived only by demanding more and more unlikely conditions. One alternative after another began giving up space to the observations, not because anyone wanted a different answer, because the star kept following the same path, because the measurements kept improving, because reality continued moving in the same direction. And as the remaining explanations narrowed, an uncomfortable possibility began standing more and more alone at the center of the Milky Way. The question had not been answered yet, but the list of answers that still worked was becoming much shorter. S2 kept moving. The orbit closed. The measurements accumulated year after year until the path around the hidden object could be traced with extraordinary precision. What had begun as a strange motion near the center of the Milky Way had become a complete record of how a star behaved under the influence of something unseen. And the result was no longer easy to dismiss. The star was circling a mass so large, and that mass was confined to a region so small that the remaining alternatives steadily ran out of room. The dense cluster explanations had survived for a time, but the completed orbit and the improving measurements kept applying the same pressure. The observations never changed. The explanations kept changing instead. What remained was the conclusion that had once seemed too extreme to accept. The dark object at the center of the Milky Way was no longer just a theoretical possibility. The motion of S2 had turned it into one of the strongest direct observational cases for a supermassive black hole. Nothing had been seen directly. No image revealed the object itself. Yet, its presence could be mapped, tested, and verified through the stars forced to move around it. What began as a single star taking an unusual path ended as one of the strongest pieces of evidence that a supermassive black hole sits at the center of the Milky Way. A single orbit transformed a hidden darkness into measurable reality.